So in this video, we're going to talk about finding the moment of inertia and also some sort of rotational kinetic energy. Okay. So what if we're given this kind of picture here, and this maybe we could say this is a picture of a diatomic molecule such as O2, oxygen gas. Okay. And we were asked to find the moment of inertia about it. Well, we're talking about the moment of inertia. We talk about how it relates to the center of mass. And so if I look at the center of mass is always smack dead right in between the middle. It's smack dead right in between the middle. Okay, so that's our center of mass. And we know the moment of inertia happens to be the sum of the mr squares. Okay, well, notice from my center of mass, I have two r's, right? I have a radius that goes to here, and I have a radius that goes to here, since those two will add up to give me my diameter. Okay, and so if I look at this, I could rewrite this as my moment of inertia to be mass times what's my radius. I went half the distance, okay? Half the distance on both sides. So this becomes my diameter divided by 2. And I square that, okay? Because that's my radius now. Plus I also have another one where I have my mass, my diameter divided by 2 squared. Okay? So if I look at this, my moment of inertia now becomes m times d squared over 4 plus m times d squared over 4. Okay. I could also simplify this to say, okay, well, I have two of those, so this will be 2m d squared over 4. Okay. I could simplify, so that becomes 2. Okay. And if I look at this, now my moment of inertia, this is now 1/2 m d squared. So that would be my expression for the moment of inertia. Okay, so now let's look at one about a rod that's rotating. Okay, we're also going to find the rotational kinetic energy of this rod. So maybe we have a rod here. It has two balls attached. So there's a rod. Okay, those are the two balls, and it has a center of mass, and it's rotating. So this is omega. So it's rotating about its center of mass. Okay. Now we're given omega to be around what? 13 rads per second. There's 13 radians per second. And maybe the mass of the two balls. Okay, the mass of the two balls is 0.7 kilograms. Okay. So the mass of the two balls. You're also given the length of the rod to be 0.4 meters. Okay. So we know the length of the rod. So this is L. So the length of the whole rod. Okay, and we know that to be 0.4 meters. So my question here is, what would be the moment of inertia about the rod? Okay, well, we know the moment of inertia. That's just equal to the sum of my mr squares. Okay? That's equal to the sum of my mr squares. Now I have two masses, okay? So if I look at this, now this now becomes my mass times r squared. So from the center of mass to one of my balls, that's an r. Okay, that's r. So r squared plus mass times r squared for the other one. Okay. So in other words, we have 2 times the mass times r squared. Okay. And so now this becomes a plug and chug. So if I multiply 2 by, well, what's my mass? It is 0.7 kilograms. So 0.7 kilograms times, well, what's my radius? Well, from the center of mass to 1, if the length is 0.4 meters, then half of the length, which is what one of the radius is, and 2 times the radius is equal to the diameter. So if the length is 0.4, then the radius has to be half of that, which would be 0.2 meters squared. Okay. So if I plug this all into my calculator, I get 2 times 0.7 times 0.2 squared. My moment of inertia shall be equal to 0.056. Okay. So my moment of inertia has to be equal to that. Okay. Moment of inertia has to be equal to that. Okay. Now we don't care about the units right now. We just want to care about the fact that we got the right answer. because we're going to do more than this. We're not just going to stop at the moment of inertia. So there goes my moment of inertia. Okay. Now there's another, before I point out, there's another way of actually doing this. Okay. There's another way of actually doing this. So I could actually just plug in right here. As you could see, I could just literally plug in the numbers at this point and I'll still get 0.056. And so, if we look at this, then my question to you would be, what is the rotational kinetic energy? Okay. So this is where the problem stops, and this is where we're going to plug in our units, okay? And so if I'm looking at this, well, we know K rotational has to be equal to 1/2 I omega squared. So this now becomes a plug-in. So if I take 1/2 times 0.056, well, what's my omega? 13. I'm not going to worry about units as yet until I get my final answer. Say I omega squared, yeah. Take an I omega squared, now this becomes 1/2 times 0.056 times 13 squared. Okay, and so this becomes 4.73 joules. Okay, because that's our kinetic energy. Okay, so again, that's the idea behind the moment of inertia, and also the rotational kinetic energy. The main point, the main point I want you to see here is the idea of how I manipulated the main point of how I manipulated the units before actually plugging numbers. Okay, so that is very important. How I manipulated the units before I plug in how I manipulated variables before I plug in my units. That is super important. Okay, that is super important.